It's key for us to note that there are two answers for this. So we have a block of mass M. It rests on a rough incline. The fact that they're saying rough incline means that there is friction. Which of the following forces must have a magnitude equal to mg? Select two answers. Well, let's do our free body diagram here. We have Fg. The force normal, and we have the force of friction, which is acting in that direction. Force normal, force of friction. Now we can break these down into their components. That means that force normal will be the same size. Force of friction will be the same size. The force of gravity perpendicular is that component, and the force of gravity parallel is in that direction. So whereas these two produce this resultant, you can also see that with these two must produce that same resultant. So we want to know which two forces could two could be equal to mg. The total force exerted on the block by the incline. Well, the incline is a force normal, and we could say there's force of friction, so this might be a possibility. Normal force exerted on the block. Absolutely not. The normal force is equal to the force of gravity perpendicular, which is a component of the weight. The force of friction clearly is not equal to. So we have eliminated A and C, which gives us two choices. The gravitational force exerted on the Earth by the block. mg must be equal to, what forces must be equal to mg? Well, for every action, there's an equal and opposite reaction. So the force of the Earth on the block is equal to the block on the Earth, and vice versa. So D is a reasonable answer, is a good answer. The total force exerted on the block by the incline, which we said was this force normal and the force of friction producing this resultant, like so, is equal in magnitude and opposite in direction to the weight. So choice A as well.